Actually, it's relatively straightforward to perform this conversion. We know what the energy density of diesel is. We know the likely part load efficiency of a diesel engine. We know the likely mechanical efficiency of the sort of drive shaft. So we know probably how much of every sort of litre of diesel's potential is going into the sort of shaft of the vapor compression cycle to cool the fridge. And the answer is about sort of probably 2.4 kilowatt hours at that initial nearly 10 kilowatt hours that you have of energy. It's a little bit more complicated than that because there are differences between electric transport refrigeration units and sort of diesel units. So that it might be in terms of some motors, just braking energy recovery. It could also be sort of solar is an incredibly popular component in these systems. That if you look at on a sort of generic basis for a sort of 10% capacity factor, and you imagine that you can cover the entire roof of a sort of trailer with solar panels, you can get some sort of quite impressive quantities of energy generated by solar panels. You can see, for example, with a single shift field operation, it's 160% of the total required energy. For the more energy intensive cycles, that you'd end up sort of around about half or sort of a quarter. In the real world, that the results will be sort of less attractive than this, and that's because that the solar panels tend to be sort of not optimally arranged in terms of angle to capture the maximum sunlight. They also, solar generation may not always coincide with when the energy is required for the trailers. There may be a misalignment between duty cycle and operating times, for example.